Alright, the first thing that you will need to do is to add color IO, which we will be using to handle errors. Once this is done, you can add the OK result type to the return type of the main function and return a color IO result so that our errors can now be formatted. You'll see what I mean later. Now let's try to read the independence.txt from our file system. As you can see, independence.txt is in the source directory. That's where we're reading it from. Next, we will turn them into characters and then we will collect them in a vector of characters and we'll take a reference to them right here. So that this now becomes a vector of characters, not only a vector of characters, a reference to a vector of characters. A reference is like looking at this vector of characters from far away without touching it, without changing it, nothing. We are just allowed to read it and parts of it, as you will see later. Next, we will create a lexer, but you are probably wondering how are we going to implement the lexer type? There's no lexer struct that I can see in this entire piece of code, right? Well, we are going to create it. First, we'll lay out the logic of what we want to do, and then we'll work on the logic. Next, we want to iterate through the lexers and print out each and every word in the independence.txt. So I want to print when, in the course of human events differently. I want each word to be tokenized. Next, let's create a lexer struct. Now, a lexer struct will hold only references to that vector, this main vector. We are not going to own it. We are not going to allocate more memory for it. It's just going to hold references to it. That's what this exactly is. We are creating a new lifetime. It is basically saying this is the lifetime of whenever this lexer is created. So right here, this entire scope is the lifetime of this lexer struct. So that's what this is. This lexer is valid for every piece of content, a reference to an array of characters, a slice of characters, which is valid throughout the A lifetime, which is this lifetime. So any vector of characters or reference to a vector of characters or a slice of vector of characters is valid only for this lifetime. I'm spending a lot of time on explaining what lifetimes are because they are a very confusing topic. So there it is. Now we're going to implement new methods for this lexer. How are we going to use it? What are we going to do with this content that we have received right here, which is a reference to an array of characters? We're going to create a method to create a new lexer right here. This method right here. We're going to create this method and then we are going to return self from it. It's going to take content, which is going to be a reference to a slice of characters or an array of characters. And we're going to return the lexer itself with this new content, right, which we are taking in right here and giving in right here. Next, we're going to create a new function trim left, which if you understand what's going on here, if you're reading it by yourself and trying to understand it, which I recommend before I tell you how it works, is if the content that we give it is greater than 0. The length of this content is greater than 0 because at one point this could be 0 because we will be mutating it again and again, as you will see later. We will be mutating it and we will be slicing out parts that we don't want for our purpose. So at one point there is a very great possibility that this will be the length of this content field will be 0. So we don't want to run this when that happens. So when the length of the content is greater than 0 and the first character is a white space, we move the entire content array to one index after the white space. So if it started, for example, if this was the string, then we are basically telling it, and this is the content, self.content, we are basically over here, we are checking if the content index 0, which is this right here, this space right here, is white space, which it is. And if it is white space, then we are going to replace this entire thing with only this part of the string. And the new string becomes very clearly this. Alright, now we can move ahead. Now we are going to make a function to get the next token in here. The next this is the main function of this entire lexer. This is the thing that is actually doing the work. The others are just precautions and preparing to do the work. This is actually doing the work. We're going to trim left right here. So we're going to remove any preceding white space right here. Then we're going to check if the left self.content.length is 0. That is, if we don't have anything, with the same thing that we are doing right now. The same thing that we are going to prevent over here. We were trying to prevent it over here. We are going to check finally if that is true. And then if it is true, we are returning none, which is an enum type of the option enum, right? Over here, you might also notice that we are returning an option of a reference to a slice of characters. All right, I hope that makes sense. This is why we are able to return none right here, because we are returning an option from this method. Next, we are going to check if the first character of self.content is alphabetic. Only if it's alphabetic, then we proceed to iterate through the self.content string. And now we keep increasing n until n becomes the index of the non-alphanumeric string character. So right here, we are only increasing n when we find that the self.content.length, as in the content that we gave in here, the declaration of independence, we turned it into a vector of characters and gave it to the lexer. While this self.content, the length of the self.content is greater than n, or n is less than this self.content, because we don't want to go out of bounds and crash the entire program, right? And if that particular character at the index is still alphanumeric, we keep moving the n so that we can actually get the words. So we will be stopping at a comma, we will stop iterating at a comma, and will stop increasing, and this while loop will be exited as at a comma. When self.content at index n becomes a comma, we will exit this loop and will stop iterating. The result will be a slice, a reference to a slice of characters from the self.content, and this will have the particular word that we are looking for, each word in the declaration of independence. So for example, n will be moving when the character at the fourth index, right, 0, 1, 2, 3, 4, at the fourth index 4 becomes a comma, the while loop right here will break, and when the while loop breaks, we will be taking from 0 to n, excluding the last comma, because this is always, a range is always exclusive. At least in Rust it is. So we'll be taking this word, and now this word is a vector of characters, or an array of characters. It's an array. It's a reference to an array of characters. So we have not yet allocated any new memory at this point. We get the word, we replace the content with the rest of the content. So we skip this and we replace this entire thing with this, excluding the word, because now we are choosing only things that are after the fourth index. The fourth index and after the fourth index, and then we will return the result, or else if it is not alphabetic, if the first instance of the content is not alphabetic, we will take out that token. For example, in this case, we will take out the comma. We'll take the comma and we'll return it as a token. So comma will be returned as an independent token. And now finally, now that we have implemented the next token, which will give us our next tokens, let's test it out. Let's test out the token. And now you will notice that we will get the first token when, as you will notice right here, it is when as well. Next we will try and go here. So our next token works. Now what we do is we implement the iterator trait on it. I have a separate video on iterators. If you want to check it out, you can. And each item that we'll be getting from an iterator will be a reference to a slice of characters. And the next function, the next method just calls the self.next token. That's pretty much it. Self over here is not the iterator. The self right here is the lexer. The trait is the iterator. And now if we go over here and we save it and then we run it, we will get each word, each full stop, each comma, everything right here in a vector of slices. But we don't want a vector of characters maybe. Maybe we want these to be collected as strings. Well, we can do that very easily. Collect each and every one of them as a string. And now we've got each and every word and it has been tokenized. This was a very basic tutorial just for beginners. I don't expect anyone to look at this and be like, oh my God, this was so underwhelming. It is supposed to be underwhelming. It is supposed to be a very basic tutorial. So there it is. Thanks for watching.